I'm sharing. Can you, Matt?
Yeah, it's there.
Okay, cool. All right, so I'm just going to go through what you can kind of expect to see on the test tomorrow. If you have anything you want extra questions about, just let me know. Remember, tomorrow the test is at 9 o'clock. I will have opened it by 8:30. So if you want to, you can jump in at 8:30. And if you cannot get in for whatever reason using the lockdown browser, then you need to meet me in Zoom, just like we are right here. You have to be on camera throughout the entire exam. All right, so the first question we're going to go over, I just want to remind you of some formulas, and you may want to write these down because they're the important ones that you need to know for the test tomorrow, is that remember that when we're talking about a parabola and like a trajectory, like if you're throwing a ball or have a rocket shot up, that HK are the coordinates of the vertex. H is the X coordinate, K is the Y coordinate. H is the time it takes to reach the maximum height. K is the maximum height. So the X value is usually the time, and the Y value is usually how high, at least in algebra classes, how high the object goes. Also, don't forget your units of measure. If you want full credit for the problem, make sure you include the units of measure. Don't just put like 5. You need to put 5 seconds or 5 whatever. So if we're looking at this is the standard or the general form of the equation f of x equals ax squared plus bx plus c. The vertex is always found by h is the opposite of b over 2a, and make sure that you have the equation in the order from the highest exponent down to the constant. Otherwise, you'll mess this up. H is the opposite of b over 2a, and then to find the height or the k value, you just take the negative b over 2a and plug it back in to the original equation. So if we're looking for the height of the parabola, you first would have to find the time, and the time is the opposite of b over 2a. And then you just plug that back into the function, and that will give you how high it goes. So let's look at an example, and this is very similar to the one that will be on the test. A gymnast jumps from a parallel bar onto a mat 10 feet below. His trajectory is described by the function h of t is equal to negative 3t squared plus 6t plus 9, where h of t is the height in feet and t is the time in tenths of seconds after jumping off the parallel bar. What is the maximum height the gymnast reaches? After how much time does the gymnast hit the mat? There's 2 questions here. So we've got a gymnast that's 10 feet off the ground, and he jumps off, hits the mat, and we want to know what the maximum height is.
Please don't hit me. Sorry.
What?
I said, please don't hit me. Horrible joke.
And also, how much time does it take the gymnast to hit the mat? So we want to know a point here. We want to know the one of those coordinates, and we also want to know one of these coordinates. So my first question is, which coordinate are we looking for here? Are we looking for the h, or are we looking for the k when I'm asking you for the maximum height?
K.
K, yes, thanks, Timothy. We're looking for the k, but we have to find the x value first, right? So that's what I want everyone to do right now. I want you to find the vertex of the parabola, because that's what you have to find in order to find the answer to the question A. What is the maximum height that the gymnast reaches? So everybody spend a few minutes and find the maximum height. And when you have it, if you'll type it into the comments, that would be great. Okay, so I'm looking at, some people are getting -1. So maybe I wrote this problem wrong. Let's see how it goes. So if we're taking the opposite of B, that would be -6 over, because remember, opposite of B, that's why I always say opposite of B instead of -B. If B is 6, then the opposite of B is going to be -6 over 2A. So H, and remember H is the time. So H is 1, and it's going to be 1/10 of a second. But that's not the question anyway, right? The question is, how high does the gymnast go? So if you found H, you found the x coordinate of the vertex, but we don't, that's not the final answer. We want to know how high the gymnast goes. So if you can, I don't see anybody typing anything in there yet. So yes, yes. Okay, so I see, Chelsea, you got it. So we're going to take that 1/10 of a second, right? And we are going to plug it into the T's right here. So our H of 1 is going to be -3 times 1 squared plus 6 times 1 plus 9. And that would be -3 plus 6 plus 9, which would be 12 feet. So the answer, the maximum height that the gymnast reaches is 12 feet. Okay. So make sure you're reading the question and you're answering the question for full credit. Then the second part of the question, part B, says, after how much time does the gymnast hit the mat? So my question for you is, after how much time does the gymnast hit the mat? First of all, what do we know the height of the gymnast is when he has hit the mat? How high is he off the ground?
0 feet.
0 feet, yes. So we know that the height is 0. So how are we going to find how long it takes for him to reach that height?
We plug in 0 for the equation to be equal to 0.
Put the equation
Solve
equal
it.
to 0. Exactly. We're going to put the equation equal to 0. So we're going to just set the negative 3t squared plus 6t plus 9 equal to 0. Right? And then I want everybody to solve that equation. Now, the last thing we were talking about yesterday was solving by taking the square root of both sides. Would we, without doing some major manipulations to this equation, be able to solve it by taking the square root of both sides? And why or why not? What do you think? Could we solve it the way we were doing it yesterday?
No, the square isn't by itself.
Right, we don't have, well, we have two squares, right? In the problem, we have one here, we have two t's, we have two variables. We have one here and we have one here. So unless we were going to be completing the square, which we are not, we're going to just have to solve this by factoring and setting the factors equal to 0. So that's what I want y'all to do. Go ahead and factor it and solve it. And then when you find the answer, type it into the comments. Anybody? Great. Okay. So we're gonna, this will factor to be t minus 3 times t plus 1 equals to 0. And then we're gonna set t minus 3, set both those factors equal to 0. Subtract 3 from both sides here and we get 3, and subtract 1 from both sides here and we get negative 1. Okay, so which one of these would we throw out and why? Which one of these would not make any sense in this problem?
-1, because there's
Negative
no such
1. We
thing as
can't have negative
-1
time,
seconds.
right? So we have to scratch that one out. Now the 3 is good, but just be careful again because we're talking about tenths of seconds. So to get total credit for the problem, you would need to write 3/10 of a second. Because there's a lot to that problem, lots and lots of places for partial credit. And hopefully most of you would get all full credit, but make sure you attempt it. If I was you, I would go back and make sure you could do this problem as well. And there's another problem like this on the other review as well. So that would be a good one to practice.
Yeah, I would word of caution. I would, if you're dividing by like that -3, make sure it's a constant you're dividing by.
Yeah,
If it's like a GCF with a variable, remember you have to take out the variable. Usually, it's like,
absolutely.
usually you get the 0 as your answer if you do that.
Right.
I've done a few examples like that.
Okay, so then if you're given a chart, this is actually a really simple problem if you know how to do it, because of the way that these are structured right now. They would get more complicated later on, but right now in this course they're not going to be structured very complicated. So it says if you're given a chart and you want to find the equation of a parabola, so I will tomorrow give you a chart and I'll say write the equation that goes along with this parabola. Goes along with this data. You know it's going to be quadratic because that's what we're working with, and I will tell you it's quadratic. So you don't have to figure out is it a quadratic or not. You will know that it is, and you'll know that this is the form that I want you to put it in because I will give you that form. So what you want to look at is where the y values start to repeat. So can you tell me where does that happen in this data? Can you see where it starts to repeat the y values?
At 25.
Right. So at 25, you can see that at 23 it's at 775. At 24 it's at 800. At 25 seconds it's back down at 775, right? So what's the vertex of this parabola?
Twenty-four 800.
Right. So what this is going to be the vertex right here. Okay, so whatever object is being thrown or shot off or whatever, the vertex is going to be at 24 seconds. The object is going to be at 800 feet. And you can tell that it's a parabola that's going downward because 775 is below 800, right? So at 23 seconds, we're at 775 feet. At 24 seconds, we're at 800 feet. And at 25 seconds, we're at 775 feet. All right, so that's our vertex. So far we know that the equation is going to be y, you can say y or f of x. Y is a, you don't know what the a is yet, times x minus, this is our h, this is our k, 24 squared plus 800. Okay, if you do that much, you get half credit for the problem because you found the vertex and you know where to plug it in. Now to find the a is super easy too. In this problem, you'll notice that each one of these is 1 second apart, and that's how it's going to be. So you would just subtract the vertex from either point on the other side. So I'm going to take, for example, 775 minus the 800, and that gives me negative 25, and that's my a. So the final equation is just going to be y equals negative 25 times x minus 24 squared plus 800. So now I want y'all to try one. This is Charmin. Okay, so profit from sales of Charmin is given in the table below. Use the vertex form of a quadratic, which is f of x equals a times x minus h squared plus k, to come up with a formula for the profit from sales of x rolls. Okay, so don't let all the verbiage scare you. You're given the formula I want you to use. You're given a set of data. So what I want you to tell me first is what is the vertex of this parabola? And when you figure it out, type it in if you will. What's the vertex of this parabola given that data? Great. Okay, so you look at the chart and you see where does the y values start to repeat themselves. And you can see at 94.55 here, and then there's 94.55 here. So the point right in between them is going to be our vertex. Okay, and then I want you to tell me what is A? What is this value right here? What is A? Yes, thanks, Aurora. You would take 94.55, either point on either side of the vertex, and subtract the y values, about 94.55 minus 9,500, and that would give me negative 45. So A is negative 45. And then you just plug it into this equation right here. So we're going to say f of x equals to A times x minus 14 squared plus 9,500. These can get pretty complicated if the x values were not one value apart but that's what we've been giving you. So it will not be more difficult than this. If you follow these steps, you'll be fine.
I was gonna say if they're having problems picking out like the vertex out of the table, a lot of times they'll look at the y value, and if you look, it's going up, and then it starts going down. So your vertex is where it goes from up to down or from down to up. So if you draw little arrows between them, sometimes people do that to see where it's going down and up.
And you're looking at the y values, because you'll notice the x values are just going up and up, because the time is going to be well, in this case, it's not time, but if it was usually the x values will just go up in this kind of problem. Okay, then transformations. So this is a summary of transformations. It is in your notes, and I'm not going to give you too complicated of transformations. Probably not more than 2 or 3 in one problem. The main thing to remember, if in general, the vertical shift is the thing you want to do last, because if you don't, it can cause you problems. And then the horizontal shift is usually what you do first, and then the reflections and the stretching and shrinking are somewhere in the middle, and it doesn't really matter what order you do them in. And this we'll post all of this. I'll put all of this in Blackboard. So, and also, like I said, you already have this in your notes. The main thing is vertical shifts last, horizontal shifts, do those first. So given the graph of f, sketch the graph of g on the same grid. So you'll have to do something like this. Now you can do it by listing points if you want. And remember that anything that is happening on the inside, do the opposite to x. And anything on the outside, do that to y. Okay, so the ones I'm giving you on the test are pretty simple just to do. Well, I say that first, at least one of them, you can just do it totally by shifting points if you want to. Like on 3A is very simple to do just by going, okay, this tells me I need to go to the right 2 and then down 3. So I would just take each one of these points and shift right 2 and down 3. Pick some nice points. Right 2 and down 3, right 2 and down 3. And you're through. Now B is a little bit more complicated. So you could still do it by just, and if you do it right, just by following the steps like we did on part A, then I'm totally happy with that. But sometimes it might be helpful, at least it is for me, to go ahead and list the points or some nice key points. And then apply the transformations. So what would be the first thing we would do, and what variable would it affect?
We do the -2 first,
Okay,
right?
and what would we do that to?
The y value.
That's right, good. Okay, so I'm going to take the -2. Remember, if it's on the if it's on the outside of the function, it affects the y values. So I'm going to take the y values, I'm going to multiply them by -2. So this would stay 0, this would become -4, and this would stay 0. And then what would we do?
Add 5 to the y values.
Add 5 to the y, right. So this would be, so here we're going to multiply the y's by -2. And here we're going to add 5 to the y values. So this would become 5. -4 plus 5 is 1. 0 plus 5 is 5. And we will plot those points, -3, 5. Um, 0, 1, and 3, 5. So you can see that it flipped. It's now upside down. It's stretched. It's now a longer parabola. And all the points shifted up by 5. So sometimes it's easier just to do the motions that are given in the problem. Sometimes it's easier, for me at least, to actually plot some points. Either way that you do it, you'll get credit if you do it correctly. All right, so on number 4, it says the graph on the right can be obtained by transformations from the graph of y equals the absolute value of x on the left. Use transformations to come up with a formula for the function. So I want you to think about that for a second. And then if you will, type in the formula that you get. Or you can just tell me, because you can't really write absolute, you can't do absolute value bars. If you want to just use parentheses where there would be absolute value bars, that would be fine if you type it in. And if you're struggling with this in any way, the easiest thing to look at is what's happening to the vertex. What happens to the vertex if it goes from here to here? What do you do to that vertex? What transformations are happening to it? How is it moving?
I got the negative absolute value of x minus 3 plus 3.
Beautiful. Absolutely. So you see that it flipped. So that means we have to have a negative. Then we see that it shifted to the right 3. The horizontal shifts, when you put them into the equation, they go the opposite of what you would normally think they would go. So since we're going right 3, you're going to have a negative 3 on the inside of the function. And then to get to this point right here, then you'd also have to go up 3. So that happens on the outside of the function and does exactly what you think it should do. Again, guys, if y'all have questions, please stop me and we can discuss it further. All right, then I'll actually ask you to do a graph for me. In this case, I'm asking you to graph using this original function, graph -2 times x plus 1 absolute value using transformations and describe the transformations. So draw a sketch of that and then tell me what you did, in other words. And if you'll type in the transformations or tell me them, that would be great. Can someone describe to me what the transformations, how would you say it in words? Anyone?
Yeah. Move the graph 1 space to the left, or subtract 1 from the x values,
Yep.
whichever you prefer.
Right.
And then multiply all of the y values by -2.
Okay. So you could say that totally. What that was Hunter, right? Was that Hunter? Who was that?
Yes, ma'am.
Okay. So he said move one left and multiply all the y values by -2. Now I would totally take that. Or if you wanted to say move shift one to the left and reflect over the x-axis and stretch by a factor of 2, that would be fine. So as long as you're describing what's happening correctly, you will get full credit for it. I would take either one of those. Okay. So some important reminders. Again, you might want to write this down, or you should have it in your notes already. But anytime you take the square root of a negative number, you always want to pull out the I first. So if you have the square root of negative, the first thing you want to think is, I have an imaginary number, and I want to indicate that by pulling out the I. So for example, if you have the square root of -50, the very first thing you would do is notice that there's a square root under the negative, which is not even possible over the real numbers. So we want to say, okay, we know this is an imaginary number, pull out the I, and then take the square root of 50, just like we normally do, by breaking it down, either using a factor tree or finding the biggest square root within the number. Another thing you need to remember, that I squared is -1. And another thing you want to remember is that when you add or subtract complex numbers, you treat the I just like it was a variable. So like if you have 2 plus 5i plus 3 plus 2i, you would just add the 2 and the 3, the real part plus the real part. You get the real part. The imaginary part plus the imaginary part gives you the imaginary part. So take a few minutes and simplify these. I don't know where my lettering kind of got funky there, but when you get C, the square root of -200, if you will type that answer in or tell me what it is. If you have a 200 or a 300 or a 400 or a 1500 or a 1700, what's a perfect square inside of all of those numbers? What do each of those have in common that's a perfect square? Oh, good, Hunter, thank you. So if you have something that's got 100 inside of it, like a 200 or 300 or 400, 100 is a perfect square. So this would be I times the square root of 100 times 2. And that's the same thing. You can always break that up. That's 100 square root of 100 times the square root of 2. And the square root of 100 is just 10. Now this is called a principal square root because anytime the square root is written in the problem, that means they just want you don't have to use plus or minus. The only time you'll ever use plus or minus is when you're taking the square root of both sides and you put the square root in the problem as you're solving it. If the square root is already written in the problem, you just use the positive. Okay, on this one right here, you're just going to FOIL it out or use the distributive property. Remember that I squared is the same thing as -1. So if you know how to multiply a binomial times a binomial, you're in great shape. And at the end, you just have to remember that I squared is -1 and do that conversion. On this one, again, if you tell me that this is 36 plus 25I squared, and that means it's 36 minus 25, which is 11, you will get, if this is a 4-point problem, you'll get 8 points counted off. So don't do that. Remember that this is the same thing as 6 minus 5I times 6 minus 5I. And then you have to use the distributive property just like you did in the problem right above it. On this last one, when we're talking about adding or subtracting complex numbers, be careful. This is a super simple problem, except for if people misinterpret it. A lot of times people see those parentheses and they think they're supposed to multiply, but you're not, because there's a subtraction sign between the two terms. So remember that that subtraction sign means that you are subtracting the second complex number from the first. Like there's an implied -1 in front of that 8 minus 2I. So this would give us 9 plus 5I minus 8I plus 2I, because we would distribute that -1. And then, oops, that's not an I, just an 8, sorry. So that would give me 1 plus 7i. Because when we're adding or subtracting complex numbers, we just combine the real parts and then we combine the imaginary parts. Any questions about any of those? Any confusion? All right, so then these are the problems primarily where we're using the new method that we learned yesterday. When you're solving a quadratic equation that does not have 2x terms, you get the square part by itself, then take the square root of both sides, and do not forget plus or minus. So anytime you introduce a square root into an equation, you have to have plus or minus, or you will be leaving out one of the solutions. Okay, so if you're looking at this, which one of these problems would we would not use the method of taking the square root of both sides? Which one? A, B, or C?
C.
Why?
There's another x term.
There's 2 x terms in it, right? So you're just going to have to factor that one and solve it just like we had been before we learned how to take square root of both sides. All right, so on A, we want to get the x squared term all by itself, right? So what would be the first thing we would do on this one?
Add 48.
Thank you. Negative 3x squared. We would add 48 to both sides. So we're going to get negative 3x squared equals 248. We're still not through though. The x squared is still not completely by itself, which is what we want. So what's the next thing we would have to do?
You get the square root of it.
Well, we will have to take the square root, but what do we have to do before we take the square root?
Divide by -3.
Divide by -3. You want to get that square, you want to get the square term completely by itself. So we're going to divide both sides by -3. Now, what do we do?
Now you take the square root.
Now take the square root of both sides, right? And don't forget what?
Take the I out.
Okay, so what, well, there's a bunch of things I don't want you to forget, but the thing that a lot of times people forget is the plus or minus. So do not forget plus or minus. And then what is the square root of -16?
4i.
4i, right. Pull out the I. And then the square root of 16 is just 4. Okay, on part B, we can also use the method of taking the square root of both sides. Because if we look at this, we have this quantity squared. So what is the first thing we're going to do in this problem?
You take the square root.
Take the square root of both sides, right? We've got the squared part all by itself. There's nothing that's being multiplied by it. There's nothing that's being added to it. We've got that parentheses squared. So we're going to go ahead and just take the square root of both sides. Whoops. So I have x minus 4 equals to plus or minus the square root of 128. Now what?
Then you add 4 to the other side.
Add 4 to both sides, Okay, you've got most credit. Everyone that's done it this much so far has gotten most of the credit for this problem. What's the last thing we want to do? Or it wouldn't have to be the last thing, but another thing we have to do to get completely all the credit for this problem.
Well, you gotta find the square root of 128.
Yes, thanks, Michael. So what would you,
Okay.
how would you do
I
that?
used my back root factoring here,
Great.
and 128 is not a perfect square.
No,
So therefore, I start factoring it. First, I divided it by 2 to find the next biggest number, which is 2 and 64.
okay,
64 is a perfect square, so that's 8. And then the 2, you need to just leave that alone.
good. Okay, so the final answer is going to be 4 plus or minus 8 times the square root of 2. Now you can leave it like that. You can say it's just, that just means you have to remember, and especially when we go into the next section, that's 2 answers. If you break it apart, it would be 4 plus 8 root 2 or 4 minus 8 root 2. But you can just leave it as 4 plus or minus 8 root 2, and that would be fine.
There were a few people throwing the plus or minus on the wrong number.
Ooh,
Yeah. So that
Oh.
plus or minus needs to go in front of the root. So it's in front
right.
the
Yeah,
number
be
that gets the
careful
square
about
root.
that. Okay, so what they were putting it with the
On like the
4?
4. Yeah, they
Uh-huh.
put it on like the 4 or something like that.
Yeah. Make sure that the plus or minus goes with the radical part. Okay, it will make no sense if that's not the case, or the part that you took the square root of. Okay, now this last one, we already established that we cannot use the square root property to solve it because there are 2 x values. There's an x squared here and there's an x here. So that means we're just going to have to factor it and solve it. So what can we factor out of this problem? What do they
X.
both have in common? X, right. Okay, so we can factor out the x. We have to leave it in the problem. Otherwise, we're going to not have, we will eliminate one of our roots. And remember, we talked about if we have a quadratic, how many roots, how many solutions do you have to have? You have to have 2. Okay, if it's quadratic, you have to have 2 solutions. So now you set these factors equal to 0. And solve for x. This one's already solved for. Here we subtract 4 from both sides and then divide both sides by 3. So the number one thing people will do on this one that's wrong, first of all, they'll try to take the square root of both sides because they've got that in their brain that that's what they're supposed to be doing, but you can't. So you have to factor it. Then they forget to include the 0 as part of their answers. So make sure you don't forget that 0. That is an answer. Questions about any of those?
What if on B you use different factors? Would it be,
I'm sorry?
What if on B you didn't use the biggest factor of as 64 and 2? Would it be wrong?
So what did you do?
Like, what if you use 16 and 8 and then you made the 16 the perfect square?
So what was your final answer?
4 plus or minus 4 square root 8.
Okay. All right. If you did that, you'll get most of the credit for that. But 8 can still break down, right, to 4 times 2.
Mm-hmm. Oh,
So
and
as
then
long as there's a perfect square within the problem, you still have to simplify it further.
okay.
So this would be 4 plus or minus 4, and the square root of 4 is 2. And then that 2 has to stay under the other 2 has to stay under the radical, right?
Yes.
So you should still get 4 plus or minus 8 root 2.
I see.
Does that make sense?
Yes.
But that's a real good question. Just keep on, make sure that you, when you look at what's under the radical, that there is no perfect
Okay.
square still inside of that number.
Okay. Thank you.
Okay, now the last question is really my kind of my favorite in a way, because it really tells if you know what you're doing, it's super easy if you know that this is the vertex formula form of a problem. So remember that when talking about parabolic trajectory, and I'm talking about like a rocket or a ball being thrown or a penny being dropped off of a tower or whatever, that h is the time it takes to reach the maximum height, and k is the maximum height. The x value is the time it takes to reach the maximum height, and the k is the actual maximum height. And also don't forget to about your units of measure. Second thing is to find out how long it takes for the object to hit the ground. You set the equation equal to 0 because the ground level is 0 feet. So here we go. A rocket is launched and has a height in feet after 2 seconds determined by the equation S of t equals negative 16 times t minus 3 squared plus 1600. And I'm hoping at this point that you look at that and you go, that's quadratic. It looks like a parabola. And the vertex would be what? The vertex of this parabola.
Three and 1600.
3 1600, right? Okay, so this is the vertex form. So 3 is our h, the x coordinate, and 1600 is our y coordinate, which is the k. All right, so when does the rocket reach its maximum height? After what? How long does it take for it to reach its maximum height?
3 seconds.
3 seconds. What is the maximum height?
1600.
Again, for full credit, you need to make sure you put units of measure in there. Then, after how much time does the rocket hit the ground? What will we do? How would we find that?
Set your original equation equal to 0.
Set the original equation equal to 0, absolutely. And the reason that we would do that is because we know that when it hits the ground, we are at 0 feet. So that means we just take the equation and set it equal to 0 and solve for our time. Okay, now this is, again, I kind of like this problem because if you know what we were talking about yesterday, what would be the easiest way to solve this problem? What method?
Isolate the square and then take a square root.
That's right. So that unless you want to make this a really complicated problem, and I have actually seen people do this and they get it right, and that's fine if they want to take an extra 30 minutes to solve it. Some people will FOIL this thing out and they'll make it into this big long quadratic, and then they'll solve it by factoring. Don't do that, because you can see that this right here, we have one x or one variable term. So that means that we can use the square root method. So what would be the first thing we would do in order to solve by the square root method?
Subtract 1600 from both
Subtract
sides.
1600, exactly. Because we want to get this piece right here by itself, right? So I'm going to say negative 16 times t minus 3 squared. I'm subtracting 1600 for both sides, so I get equals negative 1600. Then what?
Divide by negative 16.
Divide both sides by negative 16. Then what?
Square root.
Aurora, were you going to say something?
Square root.
Thank you. Take the square root of both sides. Remember, a square root and a square, they just undo each other. They're each other's inverse operations. So if you have a square root on top of a perfect square, they just are going to undo each other. So this is going to give me t minus 3 equals to plus or minus 10. Then what?
Add 3.
Add 3. So this would be the same thing as 3 plus 10 or 3 minus 10. 3 plus 10 is 13. 3 minus 10 is negative 7. And we're talking about time. So which one of those numbers does not make sense?
The negative 7.
The negative 7. So what is our answer? After how much time does the rocket hit the ground? It would be
13 seconds.
13 seconds. Okay. This is very similar. These types of questions are very similar to the ones that you will see on the test tomorrow. Is there any one that you would like to go over again or see another example of?
Could you kind of scroll through them real quick, just because I
Sure.
forgot, I can't remember.
Yeah. Let's start from the beginning. We have, first one is very similar to the last one, actually, except for that it is in standard form, and you have to know the formula opposite of b over 2a to find the time, and then to find the height, you plug that back into the problem, and then to find out how much time it takes for the gymnast to hit the mat, we set the equation equal to 0. And then
though that form of equation is called, what is that called again?
this is called the standard form or the general form of the equation.
Standard form, okay.
Mm-hmm.
That's the one with A, B, and C, okay.
Ax squared plus bx plus c, right. And that's when you use the vertex formula to find your critical point, your vertex point.
And this one is different from the last one because
the last one is
the last.
in vertex form. So the last one's actually easier because the last one is in a form where you can just look at it and see the vertex. You don't have to do any kind of algebraic equation to do it. You know what I'm saying?
So it's just more solved out more than the first one
exactly
was. Okay.
The first one you actually have to find the vertex by using that, right? And the last one you don't, as long as you recognize the formula.
Yeah, I mean, he's correct to acknowledge it's like it's the same pattern, it's the same, it's a projectile motion. So like, yeah,
yep.
it is practically the same problem. They're just giving it to you in a different format.
Yep.
What are questions
this one
contain any? Sorry.
This one, I've given this type of problem before, and I always think, oh, this is a gimme problem, I always think. But it's not, because people don't recognize that it's the vertex formula. And if you don't realize that, then it will take you a long time to do it.
Yeah, I'm just wondering, like, would we be doing any word problems? Because when I start thinking about these squares, which is a parabola, I start thinking about all the other things like absolute value and stuff like that. But the word problems would just be a parabola?
Yep, that's all we've done. We haven't done any other kind of,
okay.
yeah. So
Yeah.
the only word problems you'll see in this section have to do with quadratics, exactly.
Okay. Yeah, because I'm thinking, like, I don't know what I would do if there was a word problem where I'd have to figure out that it's like a absolute value or something.
Absolute value
like
word
that.
problems are sometimes can get really super interesting. And I think I don't know if we actually look at them in this class or not, but there won't be any on this test. And there won't be any, the only word problems we'll deal with quadratics in this section. So. Okay, so then this one is, you just have to recognize the pattern and like, what did you say, Matt? It's like if you're looking for where it starts going back down or where it starts going back up.
If you go between your Y's and you put like a little arrow, and you go up between like the 9095 and the 9320.
Yeah.
And you go up in between those, you'll go up in between those, and you'll draw an up arrow. And then the first down arrow between your first up and between your first down arrow is like where your vertex is going to be.
And then the A you find by just taking one of these numbers on either side of the vertex and subtracting the Y value of the vertex. And the transformations, just remember what affects the X and what affects the Y. If it's on the inside of the function, it will affect the X. If it's on the outside, it will affect the Y. And you can either do it by just flat out transformations, just moving the shape, which is super easy to do if it's a rigid transformation like this one. A is called a rigid transformation because basically you're just taking the shape and just moving it. This one, if you stretch it or shrink it, a lot of times it's easier to use points and apply the transformations to those points. Remember to pull out the eyes. And remember when it is, when you can use the square root method and when you cannot.
What would make up the majority of the questions, do you think? What?
The test actually looks very, very similar to this review.
Okay.
So if I was going to go back and use the review that's listed online, I would pick questions that are close to these, and that way you will be in good shape.
When will this class video be posted?
Probably as soon as we end class.
Oh, okay.
I mean, it takes a few minutes for it to.
Yeah, and I'll put the PowerPoint up also.
Okay, so this is even more similar to the test than our official test review.
Yes, but I would still, I mean, anything on that review is fair game. So I would definitely study that as well.
Thank you.
Okay, well, if there's no other questions, I will be on here for a while. If anyone wants to go over anything, has any specific questions or concerns, feel free to hang in there. Otherwise, tomorrow you'll be taking the test. And if you can't, for whatever reason, get into the lockdown browser, make sure you log in to Zoom.